An American highway stretches all the way to the horizon. A massive semi-truck thunders past. Then your eye catches something strange. A pair of wheels on the trailer isn't touching the road. The tires are hanging in midair, about 6 inches above the asphalt. It's not a breakdown. It's not a mechanic's mistake. What you're looking at is called a lift axle. But why would a truck carrying tens of thousands of pounds deliberately drive with some of its wheels off the ground? Common sense says more tires should mean more grip, more safety, and more safety, especially when you're hauling loads that can weigh up to 80,000 pounds. Yet truck drivers routinely press a switch in the cab and lift an entire axle off the road. Behind this seemingly illogical sight lies a precise engineering solution, a lesson in physics, and a surprisingly powerful way to save money. At first glance, asphalt looks solid and unyielding. In reality, it's slightly flexible. Every time a heavy truck passes over it, the pavement bends under the load. If too much weight is concentrated in one area, tiny cracks begin to form inside the road surface. Over time, those microscopic fractures grow into deep ruts and major damage. Transportation engineers discovered a harsh reality. Road damage increases roughly with the fourth power of axle load. Double the load on an axle, and the damage can increase 16-fold. That's why a single overloaded truck can cause as much wear as thousands of passenger cars. To protect highways and bridges, the U.S. Department of Transportation enforces strict weight limits. Those limits are based on a mathematical system known as the bridge formula, which determines how much weight can be carried depending on the number and spacing of axles. When a truck is fully loaded, distributing that weight becomes critical. That's where the lift axle comes in. With the push of a button, the air suspension lowers the extra wheels onto the pavement. Suddenly, the truck's weight is spread across more contact points. The load carried by each axle drops, the pressure on the road decreases, and the truck remains within legal weight limits. The system itself is powered by compressed air. Airbags and pneumatic cylinders either push the axle down toward the road or pull it back up against the frame. Depending on where it's mounted, the axle usually falls into one of two categories. The first is a pusher axle. It's installed ahead of the truck's drive axles and helps carry part of the weight from the engine, cab, and cargo. The second is a tag axle. It's mounted behind the primary axle group and provides additional load-carrying capacity while helping distribute weight more evenly across the vehicle. Today, many of these systems operate automatically. Sensors constantly monitor suspension pressure and vehicle load. When the weight reaches a predetermined threshold, onboard controls lower the axle without the driver doing anything. The extra wheels touch the ground precisely when physics demands it. But once the cargo has been delivered, physics gives way to economics. Every unnecessary tire touching the pavement costs money. The first reason is rolling resistance. Truck tires deform slightly as they roll down the road. That deformation consumes energy, forcing the engine to work harder. Lifting an unused axle reduces rolling resistance and can improve fuel economy by several percent. Over the course of a long-haul route, that can translate into significant fuel savings. At the same time, fewer tires touching the road means less tire wear. And commercial truck tires aren't cheap. But fuel savings aren't the only benefit. When a truck enters a tight turn, an extra axle can become a problem. Long wheelbases are excellent for highway stability, but they don't like sharp corners. As the truck turns, the additional axle naturally wants to continue moving straight ahead. Instead of rolling smoothly through the turn, the tires begin to scrub sideways across the pavement. That creates enormous friction. Heat builds up. Tire wear accelerates dramatically, and the resulting forces place additional stress on suspension components and axle mounts. By lifting the axle before a sharp maneuver, the truck effectively shortens its wheelbase. The vehicle pivots more easily, the tires stop fighting the turn, and the driver can navigate tight intersections without dragging rubber across the asphalt. Then, once the truck returns to a straight path, the pneumatic system lowers the axle back into position, ready to carry the load once again. So the next time you see a semi-truck rolling down the highway with a set of wheels suspended above the road, remember, those wheels aren't broken. They're not forgotten. They're part of a carefully engineered system balancing physics, infrastructure, fuel efficiency, operating costs, and maneuverability, all at highway speeds. If you enjoyed this, smash that subscribe button, and I'll see you in the next one.